Okay, so we're going to see if we can eliminate 9 rectangles by taking away 2 dots.
Well,
very interesting.
I think the obvious dot to take away would be the center dot. It eliminates 4 rectangles. Because it eliminates all of the 2x2 rectangles.
Oh, interesting. Okay.
But there's no other dots that eliminate 4 rectangles.
Well, we need to eliminate 5.
Yeah. Because if you eliminate, this one only takes away 2.
Okay, show me a rectangle that's left when you take away that one.
Well, like
It would be
this rectangle is left.
Okay.
by taking away the
The
center.
vertices can take away more. Like if you only take away this one, actually it gives you the same amount, because it takes you take this one and this one away. But you can't seem to take away more than 2.
Yeah,
for
try
your
a few
second.
more cases and see if you can see what's going on.
What if we? What if we?
You mean just from the ring?
Yeah, start now. We'll start from wherever you want to start. Take away.
So what if we remove this? Then I would remove two 2x2s and one. That would be a 3x2. It would eliminate those. Then if you eliminated this, but then you need to eliminate a corner. You need to eliminate a corner to get rid of a 3x3.
Uh-huh.
So if you took away a corner,
That still doesn't get you to. That doesn't remove all the
so
rectangles.
you have to take away a corner to get rid of the 3x3.
Oh, interesting. That's a great observation. So if you start from this, one of the rectangles we have is a 3x3. So you've got to take away a corner. Probably doesn't matter which one you take away.
Because you can just rotate it to match which one you want.
Okay.
And then what else could we do if we took away the center from here? Then it wouldn't. You would still have rectangle.
You still have this rectangle, so you need to take away 1 from this rectangle, and that gets you. You could take away any corner from this rectangle, but it gets you back to the 6
Situation that we found.
So you think
I think 7 doesn't work.
Yeah. So the maximum for
it's
3.
interesting thinking there, guys. So I'm going to show you a different way to think about it that uses something called the pigeonhole principle.
Okay.
Do you remember the pigeonhole principle? I think
Yeah.
we've mentioned it once or
Yeah,
twice.
you have like X objects that you have to stick into Y buckets where Y is less than X.
Okay, so here I'm going to think about the buckets as the columns. And I'm going to try to put 7 snap cubes in. So like you guys were talking about, we're going to only take away 2. So what do you notice about one of the columns when I take away 2?
Well, one of them is One of them is full.
All of them.
Okay, why is that going to be true?
Well, because you can't take away 1 from each. The columns don't overlap.
Okay.
Yeah.
Columns don't overlap. So when I only take away 2, I always have a column that's full. And what problem does that create now?
That creates a rectangle.
Why?
Because you have 2 vertices here, and you can pair them up with 2 vertices here.
Okay. So whenever I have a column that's full, any other column that has 2 vertices in it makes a rectangle.
Yeah.
Right? If this column's full, if this one has 2 or this one has 2. So can I have 7 cubes on here, this column be full but not have 2 in another column?
Well, no, unless you want 2 of them full.
Okay. Well, but then I would still have 2 in this column.
Yeah.
Yeah.
So it wouldn't. You would have to take away another one.
That's the problem. So the pigeonhole principle tells us that we're going to have, if we only take away 2, we're going to have at least 1 column that has 3 in it.
Yeah.
And then, since I have 2 more columns that need to have 4 in them, at least one of those is going to have 2 in it. So then we have a rectangle. Okay, pretty interesting. Now, we're going to go on to just one last pretty interesting problem here.
Okay.